What was the real message of limits to growth? Chapter 1. The book, The Limits to Growth, was commissioned by the Club of Rome and published in 1972. The authors, Dennis Meadows, Jürgen Randers and Donella Meadows, published updates in 1992 and 2004. The Limits to Growth was printed in millions of copies, but its results have often been misunderstood or misinterpreted. The imprecise summary that stuck with the book was that growth will come to an end. In fact, Limits to Growth did not talk about economic growth, and certainly did not say that economic growth had come to a halt. Limits to Growth spoke, using today's language, about growth in the human ecological footprint, in growing physical impacts on a finite planet. The aim of this presentation is to explain what the original book actually said, translating its findings into today's language, and to see whether Limits to Growth still had relevance. Chapter 2. The Key Conclusions. Limits to Growth was a scenario analysis of 12 possible futures, from 1972 to 2100. Its three main original conclusions were, using now the words of 1972. 1. If the present growth trends in world population, industrialization, pollution, food production and resource depletion continues unchanged, the limits to growth on this planet will be reached sometime within the next 100 years. The most probable result will be a rather sudden and uncontrollable decline in both population and industrial capacity. 2. It is possible to alter these growth trends and to establish a condition of ecological and economic stability that is sustainable far into the future. The state of global sustainability could be designed so that the basic material needs of each person on Earth are satisfied, and each person has an equal opportunity to realize his individual human potential. 3. If the world's people decide to strive for this second outcome rather than the first, the sooner they begin working to attain it, the greater will be their chances of success. The fundamental message. The three conclusions can be summarized as follows, using modern language. Unless special action is taken, human resource use and emissions will continue to increase as a consequence of growth in population and human activity. Importantly, this human footprint, if unchecked, will grow beyond the carrying capacity of the globe. That is, beyond what the globe can provide on a sustainable basis. If such expansion into unsustainable territory is allowed to happen, decline, or collapse, in human resource use and emissions becomes unavoidable. Chapter 3. Explaining Limits to Growth, Understanding the Basic Principles. In order to understand the fundamental message of limits to growth, it is useful to understand the concept of the ecological footprint, the nature of global limits, the difference between linear and exponential growth, and the possibility of growth beyond limits equals overshoot. The human ecological footprint. This is the total environmental burden caused by humanity. It is the sum of humanity's use of resources, renewable and non-renewable, humanity's emissions of different forms of pollution, and humanity's destruction of biodiversity. It can be measured as the land area necessary to produce the food, fiber, fish, meat, etc. that we need. At current technology, the average world citizen needs 1.8 hectares to keep his current standard of living. Limits. Limits to Growth looked at several different limitations on human activity. Access to non-renewable resources, such as fossil fuels, minerals and metals. The abundance of such resources in the Earth crust is clearly limited. In the long run, we are limited by how fast we can find substitutes. Access to renewable resources, such as wood, fish and water. The supply will decline if we use more per year than the globe can provide within a year. If we catch fish faster than the fish stocks can regenerate, then we draw down the resources. If we do not reduce the fishing effort, stocks will go down further and eventually collapse. This happened to the cod in Newfoundland in the early 90s. The ability to get rid of environmental emissions, such as climate gases and toxic effluents. If a little sewage is added to a lake, it will be absorbed without damage to the water. But you add too much sewage, you kill the lake and its absorptive capacity. This is already the case with CO2, the pollutant from fossil fuel use. The difference between linear and exponential growth. Take population. You have linear growth if the population grows by a fixed number of people every year. You have exponential growth if the population grows at a fixed percentage every year. Overshoot. To overshoot means going too far, to go beyond the limits. If you cut too many trees every year, the forest will soon be gone, in spite of this recurring regrowth. If you build too many fishing boats, they collectively will catch more than the fish population can endure. As a result, the fish population will break down, and the ships will be idle in the harbour as lost investments. Chapter 4. The environmental impact of human society increased greatly from 1900 to 1972, in some cases with exponential growth rates. Limits to Growth said that the human ecological footprint cannot continue to grow indefinitely, because planet Earth is physically limited. Humanity cannot, in the long run, use more physical resources and generate more emissions every year than nature is capable of supplying and absorbing in a sustainable manner. Limits to Growth said that the human footprint is likely to overshoot the physical limitations of the planet because there are significant delays in global decision-making. When limits start approaching, society will initially spend time discussing their reality, while growth continues to expand the human footprint into unsustainable territory. It is self-evident that human resource use cannot exceed what the globe can provide for very long. The human ecological footprint will have to move back into sustainable territory, either through managed decline to sustainable levels of activity, or through collapse to the same levels, through the brutal work of nature or the market. An example of the former would be to limit the annual catch of fish to the sustainable catch through legislation. An example of the latter would be the elimination of fishing communities, because there is no more fish. Limits to Growth provided an optimistic answer. It said that forward-looking political action can prevent humanity from overshooting planetary limits. The 12th and final scenario, the Sustainable World scenario, showed how it could be done, at least in principle, by stabilizing the world population and the industrial output per person, and by the use of technology to preserve resources. In essence, Limits to Growth said that if society succeeds in avoiding overshoot, there will be no need for managed decline or any threat of collapse. Limits to Growth said that it was important to start early in order to achieve a smooth transition to a sustainable world, without passing through overshoot and contraction. Chapter 5. Summing up. The fundamental message of Limits to Growth. Global society is likely to overshoot, and then be forced to decline or collapse because of significant reaction delays in the global economy, caused by the time society needs to identify and accept global limits, by the institutional delays involved in decision-making, and by the time it needs to show result once action has been taken. Chapter 6. Has the message of Limits to Growth stood the test of time? Interestingly, over the 40 years since 1970, the real world has followed scenario number 1 in Limits to Growth. This is the so-called business-as-usual scenario, the world model standard run. Population and economy has continued to grow as they did in the decades before 1970, and as a consequence the world moved into overshoot. This apparently occurred in the 1980s. Chapter 7. A new concept of growth. If we measure progress in an increase of quality of life, and not of material turnover, then humanity can grow for a very long time. It would grow in terms of security, happiness, stability, and sustainability.